Okay, hello everyone. My name is Fumeng, and I'm going to present this paper, the backstory to summon the public. So recall year 2020, when we had a virtual conference during the pandemic, and then we experienced an election week. Like many of you, I refresh my browser a million of times during that week, and sometimes I log into my Twitter account to check if there was any news on the vote counting progress. Every time I open my Twitter page, Matthew K's account popped onto the top. He kept posting his animation about election circumstance, and I feel that this person's anxiety level was no better than mine. In 2021, I finally spoke to Matt about our shared experience during the election week and agreed to study incentive transition for election forecast. In late 2022, we built our own forecasting model for the government elections in 33 states and construct this forecasting website to measure people's emotion, trust, and intentions before and after elections. This work was later submitted to VIS2024 and won a Best Paper award. While it took us 9 months to design the website, this original paper presents only the final website design, the launcher experiment, and the results. For me, I do feel that I learned more from the designing process. And this year, we decided that we should share what we have learned with the research committee. Here comes this backstory paper, which presents our design space, interviews, revisions, and design knowledge we've learned. For me, I do believe this paper gives us a rich set of original knowledge. And right now, I'm going to open the very first chapter for you. So at the very beginning, we did not have clear research questions. We did a literature review, a formative survey, and had extensive discussions with our collaborators from political communication and journalism. After 4 months of discussion, we finally had more confidence in this research direction and started to explore the design space, which we divided into 3 subspaces. I start with the data subspace. To think about the underlying data, we think about what the quantities in an election forecast we must convey to a viewer. So an election forecast is a prediction of vote share. At least we should convey a predicted vote share, or maybe probability density of the vote share distribution, or a summary of the probability density, which could be a win probability or a loss probability. And we can use one distribution to simultaneously show both candidates, or we can use one distribution for each of the 2 candidates. We can summarize one distribution into a point or interview estimations or a text description. We can also discretize it into a dot plot or a density bar graph. So these are the 3 axes within the data subspace. Next, I will talk about the visual representation. For visual channels, a density bar graph uses position and length encodings, in which we can further decode the probability density using luminance or colors. For a dot plot, each dot represents one possible draw from the distribution, so we can use angles to represent the vote shares within one draw. And then similarly, we can use length to represent the vote shares within one draw. These are some of the possible visual marks we can use. Then to think about how to lay out these different marks, we can use a Cartesian coordinate system, or maybe a natural extension is to use a polar coordinate system, like this centrifugal layout or a centripetal layout. We can also use a loosely defined coordinate system, like this grid layout or this B-swan layout. If we have 2 distributions, we can use a juxtaposition layout, a reflection layout, or a blend layout. So these are the 2 axes within the visual representation subspace. We also consider what animations we can use for the data and for the visual representations. Think about animation narrative. If we do not have a clear narrative, this could be a hypostatic outcome plot. We can use accumulation or dissipation narrative, which means that we gradually remove data or add more data onto the screen. I think what's new in our design space was that we also categorize different analogies we can use for the narrative. If we associate the narrative with an abstract process, we call this an abstract analogy. And if we associate this process with a natural process by their forms, we call this a figurative analogy. A step further is to associate the animation with the underlying data generating process, which we call it a mechanistic analogy. The example here shows how we use animation to present Bernoulli distribution by normal distribution, which finally approximates a normal distribution at the bottom. Animations can also have different configurations, like the number of dots to be animated, if we include any visual effects, and finally, if we use different coloring strategies. So these are the three axes within the animation subspace. We combine different axes and values and implement about 45 different prototypes. 45 were way too many for real-world elections, so we had to carefully evaluate and select them. We asked our lab mates to give us the first round of feedback, which helped us narrow them down to 10 prototypes. Here I show 8 of them. First tags, we show both the win probabilities and the predictable shares. 1 dot plot, 1 discretized distribution. 2 dot plot, 2 discretized distribution, and its animated version is compass, which also used a polar coordinate system. We also have needle, which use just 1 distribution, but a different visual encoding. And to test the ongoing encodings, we have mint, and to compare different analogies, we have particle and plane code. So we use these 10 prototypes for semi-structured interviews with 13 prolific participants, and then use qualitative coding to arrive at 6 insights and 10 reactions. The most important insight was that we realized participants tend to mistakenly construe concrete visual encodings as real-world concepts. So a dot in a dot plot represents 1 possible draw from the distribution, 1 possible election outcome. But participants mistakenly believe a dot represents a real-world concept. This could be a vote, a person, or a poll. And this misinterpretation lets them falsely believe that a competitive election is decisive, which further influences their trust in forecasts and actions during elections. There are other insights from the interviews, but all of them pointed to one conclusion, which was that our original designs were confusing. We had to revise them. The most important revision we did was to add annotations. We added symbolic annotations to show the meaning of each dot, because we feel this equation format was easier for participants to understand. And we also divide the annotations into sentences, because empirically we feel that participants were more engaged when they read the annotations as sentences. Finally, Meta and I disagreed on how much annotation we should have. I thought that we should have as short annotations as possible, while Matt thought that we should have as more annotations as possible. Well, these two opinions do not completely conflict with each other. So as a result, we have many annotations, but they are all short sentences. Okay, in the end, I'm going to quickly show you the final versions we have from the paper, the original paper, and the website. 1 dot plot, 2 dot plot, 2 intervals, and the plane code with many annotations. Based on our original paper, these final designs were satisfactory. We did not observe as much confusion as we did in the interviews. Looking back, I think the primary challenge we were facing was to make real visualizations that real people from the real world can really understand. So think about a typical visualization study. We normally design visualization for a few very abstract tasks and under an abstract context. But in the real-world scenarios like elections, people turn to use visualizations for a variety of different tasks, and some of them can be very vague. And their prior knowledge and beliefs turn to bias them towards one direction or the other when interpreting a visualization. So for me, I think to achieve ecologibility is still a huge challenge for the visualization community. Thank you so much for listening. I'm happy to answer any questions.